Hello everybody, welcome. This is paper 1 from May 2022 and this is time zone 1. So I think this is actually quite a challenging paper. Question number 5. The ticket prices for a concert are shown in the following table. And we have tickets for an adult are 15, child are 10, and student is 12. A total of 600 tickets were sold. The total amount of money from the ticket sales was $7,816. And there were twice as many adult tickets sold as child tickets. Let the number of adult tickets sold be X, the number of child tickets sold be Y, and the number of student tickets sold be Z. Write down 3 equations that express the information given above. This is kind of an interesting question, I think. So what do we have? I'm actually going to use a few different colors. Let's say X, and then Y, and then this is Z. So they told us that X is the adult tickets, Y is the number of child tickets, and the Z is the number of student tickets. So we want to write down 3 equations, and they give us 3 pieces of information here. We have X plus Y plus Z. So what's one equation we know? We know that all the tickets we sold add up to 600. So we know that adult, maybe I shouldn't have chosen 3 colors, but here we go, adult plus child plus the student tickets, all of this will equal to 600. So remember, this is X corresponds to the number of, in this case, child tickets sold, adult tickets sold, student tickets sold, and so on. So X plus Y plus Z, this equals 600. That's how many tickets we sold. The total amount of money from ticket sales was $7,816. So what do we know? We know that for every adult ticket we sell, we make $15. So we have $15 for every adult ticket. Remember, X represents the number of adult tickets that we sell. So $15 for every adult ticket, plus we get $10 for every child ticket, and then we also have $12 for every student ticket. And altogether, that should equal $7,816. So X, remember, is our foundation, kind of our variable that we're working with. It's the number of tickets of each type that we're selling. All right, last part, let's try to use this equation right here. There were twice as many adult tickets sold as child tickets. Twice as many adult tickets sold as child tickets. So for these kind of questions, it's hard to know which one goes on each side. So let's write adult ticket equals and then child ticket. But we don't know, but it isn't the case that the number of adult tickets is equal to the number of child tickets. There were twice as many adult tickets sold as child tickets. So X is the number of adult tickets. Number of adult tickets. It doesn't equal the number of child tickets. We have more adult tickets sold. Number of adult tickets equals twice the number of child tickets. So there were twice as many adult tickets as child tickets. So if we sell, let's say, 1 child ticket, then we would have 2 adult tickets sold. So if you want, you can even just put in some values of this. This is X and this is, let's say, Y. And if we imagine working this equation, when we sell, let's say, for every 1 adult ticket, we would have 2 X's. Let's say for 5 adult tickets. So if Y is equal to 5, then our adults would be equal to 10, and so on and so on. 10, this would be equal to 20. And so this equation right here seems to work. For every single child ticket sold, we have twice as many adult tickets. That's an equation which relates the number of adult and child tickets. Okay, write down 3 equations that express the information given above, and part B asks us to find the number of each type of ticket sold. Okay, so what do we have? We have these 3 equations right here. We have one which is X plus Y plus Z is equal to 600. this second equation, 15x plus 10y plus 12z is equal to 7,816, and then we have one more equation right here, which says that the adult tickets is equal to 2 times the number of child tickets. Okay. What can we do? 3 equations and 3 unknowns. For this, we could use linear solve. So if we have a bunch of equations, this case we can't graph it because we have x, y, and z, and our graph only works for x, y, 2 dimensions. So in this case, we're going to need to graph this. Oh, sorry, not graph it. We're going to need to use linsolve. So let's go menu, let's go algebra, and solve a system of linear equations. Here we have variables x, y, and what's going to make this kind of tricky is we're going to have 3 equations. And the calculator works it out for us already. It gives us x, y, and z. And now after that, we'll put our values in our equations. We know that x plus y plus z is equal to 600. We know that 15x plus 10y plus 12z is equal to 7,816. And the last one, we know that x is equal to 2y. Number of adult tickets is equal to 2 times number of child tickets. Let's go ahead and work this out. And this is a solution to this set. And just to kind of double check, I mean, first thing, there's no fractional values, which is good. So we're not selling fraction of a ticket. And what this means is, remember x, y, and z, this is the number of adult, child, and student tickets. So x plus y plus z equals 600, 15. So this is the set of values that satisfies all of these. And here we have number of adult is equal to 2 times the number of child tickets. So this is a set of values that satisfy all of these. Okay, so find the number of each type of ticket sold. Let's go back to the document. This is part B, and we know x is equal to 308, y is equal to 154, and z is equal to 138. So the calculator gave us this, right? This is x, this is y. That's what it normally gives us when we have 2 coordinate points, but when we have 3, they also include this value of z, and we can still work it out as x, y, and z, and so on. And remember, that's what these mean right here. Okay. All right, everybody. I hope that was helpful, and as always, best of luck. Take care.